Good morning, Year 9. Today, if we have a look at our learning intentions, we are going to be looking at the length of an interval. We're going to use Pythagoras' theorem to find the length of an interval using a right-angled triangle with the interval as the hypotenuse. Okay, so let's have a look in the first place. Now, if we have a horizontal line graphed, then to find the length, it's simply the difference between the two x coordinates. So if we've got this one plotted here and we've asked the length, we can either just count them, how many we've got, and we've got 3 to there, and we've got another 4 there, so the length is 7, or we can calculate it using the x coordinates. And my two x coordinates are b is 4, a is minus 3. I can get the length from subtracting those. So 4 minus 3 is equal to 4 plus 3 is 7. But I do emphasise in this one, you can actually count them. So whatever you do if you go and calculate it, probably a good idea to practice calculating using the points. Make sure that you get the answer right. You can just check. Okay, the same thing with a vertical line. If we've got a vertical line between point A and point B, then it's simply the difference between the y coordinates. Again, we can count them. We've got 4 there, we've got 5 there, so it is 9 units. We can read them off the graph and calculate from the y coordinates. So this y coordinate, A is 5 and B is minus 4. Now, it's important to realise that our length is always positive. So do not, if you come up with a negative answer because you do them the other way around, just get rid of the sign. But anyway, the length of this one, 5 minus 4, is the same as 5 plus 4, a negative and a negative, which gives us 9 units. So they're pretty straightforward. If they're horizontal or vertical, we can just count. Now, if it's an oblique line, which is a slanted line, we can't count them to come up with our number, our answer. What we need to do is we need to use Pythagoras' theorem. Okay, so what I might just do is come down here first. So Pythagoras, in Pythagoras' theorem, if this is our hypotenuse, then what we've learnt is that the sum of the square of the hypotenuse is equal to the square of the hypotenuse is equal to the sum of the other two sides. So AB squared, that hypotenuse there, is equal to x squared plus y squared. So if I make them all lovely and colourful, we've got AB squared equals x squared plus y squared. Now we want to find the length of AB. So if we're finding the length of AB, we've got to find the square root of AB squared is equal to AB. So AB is the square root of that thing. Whatever we do on one side, we do on the other side. So AB is equal to the square root of x squared plus y squared. A couple other things, if we have a number under the square root sign, it's called a surd. Now a surd is an exact number, it's exact form. Any number, which is the square root of 5, for instance, the square root of 3, any number we have under here, that's an irrational number. The only way we can give it an exact form is to leave it as a surd. Otherwise, the digits just go forever and we give an approximation to a certain number of decimal places. So again, as I said, then this length is always positive. We're always going to come up with a positive answer for length. And the last one is make sure you use units for the unit of measurement. Here we don't have centimetres, we don't have millimetres. Things can be to different scales. We have units, which is what we use when we don't have a centimetre or millimetre or metre, etc. length. So if I just come back up here and have a look at this one, length of an oblique interval slanted, we can use Pythagoras' theorem to work out the length of this interval. What we're going to do is we're going to draw a right angled triangle under the interval. The length of the interval is the hypotenuse. So there was my A, there was my B. I drew this right angled triangle underneath like we did the other day. And then for this one, I just counted them up and saw how many I had. So I counted up 2, and I had 6 here. So that was equal to 8. With this one over here, I had 6 and I had 4. That was equal to 10. So just like on our gradient, we've got our lengths. AB squared is going to be equal to 8 squared plus 10 squared. Now you don't have to put this one down on paper or anywhere else. You can put that in your calculator if you want to. I've written it on there just to show that line of working. But you will normally put this in your calculator right here, and you will get an answer of 164. So your AB is going to be equal to the square root of 164. If you're asked to leave it as an exact distance or to leave it in third form, that's your answer, square root of 164. If you're asked to give it to 2 decimal places, for instance, then we use the square root function in our calculator, and I get 12.81 units. I guess if I can find a calculator, I should quickly do that again and find out what it was before and it was it was actually 12.806. So I rounded it up to 12.81. So it's 12.81 units to 2 decimal places. All right, now quickly having a look, I just did one more example of this. And this might be what the question might ask us. It might ask us to find the length of the interval between points A 4 minus 2 and B 4 3. We might have to plot them. So I've plotted A and I've plotted B. I've drawn my triangle underneath. And then I've measured or calculated the length. So I've just counted them. I've got 8 here and I've got 5 here. So then I've got my Pythagoras. Pythagoras is AB squared, which is what we're trying to find here. AB squared is equal to 5 squared plus 8 squared. So in this occasion, I haven't written those two down. I've just put them straight into my calculator and got an answer of 89. And now I'm doing my AB equals the square root of 89. Now I've left this, I should have put up the top there. I've leaving this as the exact number. That's left as a third. Now today what you've got is you've got this worksheet to do. A lot of it is asking for what you to do. It's asking you to leave them. Where is it? Well, that's the example at the top. So if it says here, leave your answer as a third where necessary. So what it means by is necessary. If it, for instance, ends up being a square root of 25, you will, and that's exactly 5, you will give your answer as 5. So I'll just scribble that on here. So if we end up with, come on pen, if we end up with square root of 25, that answer is going to be 5, so you might put them in your calculator anyway. If you end up with something like the square root of 24 and you put it in your calculator and you get 4.98, blah, 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 just leave it as that. So you might have to test first to see whether you're going to be leaving it as a third or whether it's going to work out to be an exact number. Anyway, have a go at all these. As you can see, you've already got intervals, have already got the triangle drawn for you for all of them. You will need to count up the units. These ones down the bottom, you will need to draw your triangle for. Okay, have a great day and send me an email if you've got any problems.